You're looking at recognizing the pattern in each sequence in the table. Okay, so I would want to teach you guys one thing over here, one or two things, something called as factor. Factor that we are considering, so factor under consideration. So this I want you guys to understand. This is something that we are doing it indirectly, but let us put it in terms of words. So when I tell factor under consideration over here in this figure, we're looking at, say, number of, it can be sides or vertex, but let me go with sides or vertex. Vertex are nothing but your corners, okay? And according to this factor, then the sequence or sequence, I'll call it as SEQ from now onwards, would be 3, 4, 5, 6, so on and so forth. So now what I want you guys to do is pause and think about what can be the factor. Again, my factor can be different to yours, and we both can be different to third person. So there's no fixed factor over here. So main idea here is to think how many factors can you think of. I think that should be the case. Looking at the sequences, I think you guys have been used to it now. That is not a big deal. Now think about what can we consider so that it makes sense, or we have different sequences, right? So that is more important than just writing the sequence. Oh yeah, you need to pause and think. Okay, one factor that I can think of is number of lines that I see in each structure. Another factor that I can think of is number of dots or vertex, number of corners, number of angles. One more factor that I can think of is number of diagonals. Diagonals is something that we'll talk in the future. One that I want to discuss over here is number of lines coming out of a point, or another name for this is vertex. So there are 2 points, and the number of line coming out of a point, a single point, not both the points. A point would be how many? Yes, 1. So what I want you guys to think of is, or do is, consider the sequence. Let's make a table, shape and the number of sides. Sorry, number of lines actually in this case. Let's make a table. Yeah, again, I want you guys to pause and think over. For K2, the number of lines coming out of a point is 1. For K3, the number of points coming out is, say, this is 1, this is 1. So this is basically 2. For K4, it is 1, 2, 3. Can you see the sequence? Can you predict what will be K5? Let's have a prediction. K5 according to this will be 4. Let's see if our prediction is right. So we have 1, 2, 3 and 4. Did we predict it right? Yes. So we have a hang of it. So now since we predicted, we'll be able to, let's again verify that, if we are in the right sequence. K6, there's supposed to be 5 lines coming out of a vertex. 1, 2, 3, 4 and 5. So there are 5 of it. So we got it right. So can you think of how many lines will be coming out of a vertex in, say, K100? Correct, 99 lines. So basically, I can term it this way. This is your, say, formula per se. This is known as a formula. What is that? What is a formula? It's a general form of whatever you're thinking of. That is given, say, a side n, right? Given given kn, the number of lines coming out, right? So the number of lines will be equal to number of vertex minus 1. This is a generic form of the idea. And such a thing is called as a formula. Okay. Right. We consider a factor. According to that factor, we kind of wrote few numbers and then we predicted. This were our prediction and we got to predict and verify. So once we have that, then we can do a lot more prediction and a lot more verification. And once that is confirmed, we can write a formula. Okay. Again, this is extra bit of things that I'm teaching. All your question talks about is what is the sequence and what is the factor. Actually, not even that. What is the sequence, right? That's the actual question, but I'm changing it to a bit more. Here, what else? Here we have what is the factor according to you guys. You can think of it. That's left to you guys. It can be, yes, number of squares or smaller squares or smaller box. Let me use the word smaller boxes making up the larger structure. Again, that's left to you guys what you want to do, how you want to write it, or what factor to consider. The sequence will be 1, 4, 9, 16 because we are used to. I just went with it. What about this? What can be your factor? Again, it's left to you guys. What can be the factor? Number of smaller triangle making up the larger structure. So the sequence over here will be 1, 1 plus 3, that is 4, 4 plus 5, that is 9, and as you can see, this 2 will be a square number. Very simple. Now, this is a bit complicated. Again, I want you guys to pause and think over what is the factor that we can consider and accordingly what will be the sequence. Let me use the entire space. Here we can consider something called as number of bumps or number of sites. Actually, that will be much easier. Number of bumps, I think it's a complicated relationship. So number of sites. So let me take up the first structure. So the structure goes like this. You have a triangle. Actually, it's supposed to be equilateral triangle. Then you divide that into a side into 3 equal parts. This is how a snowflake is made. 3 equal parts you have to divide. Erase the middle one. And then you add the bump. Okay. You form the second structure. How do you form the third structure? You erase the, divide the side into 3 parts. Erase the middle part. Again, if you do a good job, you'll get this. Actually, you should be doing this. And then join it. And you form the third structure. And you see that it's the same. I missed one over here. So every time, by what factor are we increasing the number of sites? It would be so throughout actually. The sequence will be the following. First one has 3 sites. Quite simple. Second one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we have a factor of 4. Is it not? So I feel that since there are not many structures, I need to be a bit choosy. I mean, bit jugaad. I should try to predict and see. So next one should be, according to me, into 4. So that's 48. Let's have a look. It's not going to be easy, but so each of this structure, let me actually just consider one structure, one small structure. So 1, 2, 3, 4, 5, 6, 7, 8. 6 8s are 48. Yes, we got it right. So what I did was, let me zoom in. It might be small for you guys. Yeah, right. So there is 1, 2, 3, 4, 5, 6, 7, 8. So each of this has 8, and there are 1, 2, 3, 4, 5, 6. So each of this circle has 8 small lines, and there are 6 of them. So 6 8s are 48. So we got it right, and so our number will be 48, so on and so forth. So in general, what can we tell? Just take the previous number, multiply that with 4, and you get the next number. That can be your formula if you guys want to write a formula. So number of sides will be equal to 4 times of previous figure's number of sides. As simple as that. Okay. So again, just writing the sequence is your agenda over here. What I wanted you guys to understand, a new word is factor, because this is very important. It is what can be used in different scenarios. Like, I'll give you a big fat example, say artificial intelligence, or decision making, or decision making when it comes to corporate, when it comes to or traveling somewhere. There are many places we use factors. Actually, day-to-day activities happens because of considering different factors. What is there in the kitchen, so that we can, this will be the dish for the day. If a certain item is not there, then that dish will not be cooked. As simple as that, right? So here the idea of factor is very important. I hope you guys have different set of ideas, or considering different factors over here and writing the sequence. At least think of the factors. If you don't want to write the sequence, left to you guys. So now you can pause and have a look at, and finally, once we have this factor sequence, and according to this factor, we can make a formula and predict things. Okay. Or we can look at the factor by taking into another factor. Anyways, let me not complicate for you guys. This is good enough. You can pause and have a look.